Yes, Graham, what's up, dude? Turn my lights on. Like music.
Hello.
What's up, Graham? How's the summer going?
It's going good. I've just been working all summer. I got like 50 bucks free.
What are you saving up your money for?
Nothing, honestly. I just started saving up my money right now.
Oh, because what were you spending on before, dude?
I've been spending on a bunch of things, like a bunch, like the mall.
The mall will take all your money.
I went to the mall. I went to the mall with a friend. So. So yeah, that was fun.
What'd you buy? Did you buy a bunch of clothes? Did you go to Aeropostale, Hollister, Abercrombie
I
Fitch?
just bought some food and bought some stuff for my sister.
Well, that's nice of you. Nice to be nice to your sister. Sisters help you out. I didn't know you have I didn't know you have a sister. I have 5 sisters.
Yeah, I have a sister and a brother. I have 2 sisters.
Oh, I know about Ramiro. I know Ramiro. Is Ramiro the oldest?
Yeah. Well, technically, second oldest. The one in Mexico is the oldest.
Oh, you have a sister in Mexico that you don't have over here. Okay.
Yeah.
She's
24.
She didn't make it? Didn't make it or something? Like.
My mom had her when she was like a baby, and my mom came to the United States after she had her. Yeah, but my grandparents didn't want to let my mom take.
Oh, take her. Okay, I got you. Yeah, she's too young. Got you. That's okay. Cool. Is it hot in Texas? I imagine it's pretty hot.
No.
Nah. It's nice.
It is.
It's nice in California.
That's why I hate being home. I'd rather be at work. There's air conditioning.
There's air conditioning, right? Dude, I remember. So here in LA, usually doesn't get very hot. So I actually don't have central AC. I have some air conditioning units I'll use every once in a while.
Our air conditioning is broken at our house right now.
Oh no, dude. Dude, that's dangerous, bro. You can look die from that in Texas if you don't have your AC working.
Yo, Gold,
what's up, dude?
Deal with 9 sisters, bro.
5 sisters. I got 5. Only got 5.
Oh, 5. Yeah. How do you deal with them?
How do you deal with them? Very carefully. I tell you, I didn't ever really get to pick the movies or anything when I was, in my day, we had to go to Blockbuster to go rent a movie. If we wanted to go see a movie, and even Blockbuster was too expensive. My family was poor as fuck. So we would go to the local Kroger or Randall's or something, and they had a movie rental in there. And I remember my mom always being hot new releases, new titles that had just come out were $2. And my mom no, we can't rent those. You can only get the 99-cent specials. So we'd have to rent movies that had been out for a couple of years. And I don't know, it's so interesting. You guys grow up in the days of Netflix where you can watch whatever you want all the time, which is cool.
Yeah, but it's more than $2.
Free movies, yo.
Yeah, it's $10, but it's $10 for as many movies as you want, all month. Back in my day, we had to rent them, right, and then we had to return them before we could rent another one. Gabriel says we download movies. Yeah, you're right, Gabe. Yeah, and that's what actually happened. Once I got into high school, I became a part of a lot of private trackers for BitTorrent and stuff, and then I just downloaded everything. It was that was the end of it. Yeah, that's when I got to choose what movies I got to watch. What's up? What's up, Grim?
I said W Gold. What day is it today?
Today's Wednesday. Today's Wednesday, the 14th of June.
Dude, I don't even know what day it is.
I know, right? This is the problem with the summer sometimes, dude. The time just goes by. I'm still teaching. I still have one more kid with a final on Saturday. And then I'm going to the forest for a week, so I won't be here for a week.
The forest?
Yeah, I'm going to go to Electric Forest for a week. It's a pretty cool place. I think you guys have seen photos of me there before.
Where are you going, my boy? Yo, take us with you, bro.
I know, right? Yeah, here. I probably have a picture.
Electric Forest, bro.
Dude, Electric Forest is great, dude. It's awesome. Here, I'll get you guys some pictures of it.
Today's my day off, so I'm just here.
That's
Just
cool.
chilling.
I'm glad. Do you want to play some
Same.
Warzone, dude? The new season of Warzone's out. Season 4.
I have.
Go update it. Go update it right now. Go update so we can play it
My
later.
computer's been in my closet. My desk.
What
broke.
about go
My
get
computer-
Ramiro's Xbox or something?
Oh god. I need a
Bro's
controller.
playing in the closet.
Plays in the closet, dude. I literally stream inside a closet. Y'all have seen my setup. I literally stream inside a massive closet.
My the Xbox needs a controller. So.
Oh, okay. Okay, go get a controller.
Yo,
I
chill.
don't have a-
You may get you a
I don't
controller
have a
too. I
desk.
can get you a controller.
Grim came
My
out of
bad.
the closet just now.
Here, this is Electric Forest. This is Electric Forest. This was the crew I went with last
For
year.
free? Oh,
Uh,
how about you take?
It's in
like,
Michigan.
this-
Dude, it's really dope. It's
Oh, how about-
it's a music festival in the middle of the forest. It's like it's
Oh,
literally
yeah,
the
so
best.
that's what you
Yeah, so
Oh,
yeah,
you know what you should
your
do? though?
story on Instagram.
yeah. I found
The quests or whatever.
some- Someone gave me some gold glitter for like my beard
no.
at one point. Oh, this is pretty funny.
Oh,
Gabriel,
what
just
you
raise
do?
your hand, dude. Here, you can come up. I'll invite you to speak. Come speak, Gabe. You're cool, dude.
I thought
Oh, do you
someone
know what
already
you
Just
do?
me like playing some piano. Yeah, this is pretty fun.
Oh.
What the hell?
Oh yeah.
have
See this?
piano
Like
with
it's like a little organ or something. They just had this set up in the forest, so I just go and I just start playing, and then there's these people, and they just like chill around and stuff. It's pretty cool.
So they allowed you to play, or you had to?
No, anybody can just go up. Anybody just go up.
Okay.
Not a lot of
No,
people.
it's-
Not a lot of people have a lot of courage to like go up.
Oh, yeah.
You know, because it's kind of like a stage fright thing. You got to go up and like just perform in front of random people, and everyone's like tripping anyways. So like, it's a whole thing.
No one gives a shit.
Yeah, dude, it's pretty cool. Yeah,
They're
it's-
like music.
yeah, and dude, this
You
is
know
the
what
middle of
you
like
did?
a rave, so there's like a bunch of like speakers and stages going on everywhere, dude. It's nuts. Yeah, it's super cool.
Well, you know what you do? You know
Yeah,
what you
there's
do,
me. Yeah. Oh, then this was a party. I DJ'd this party. There was like an after party in the campsite, and I did this one. This was pretty fun.
bro? Am I invited?
Yeah, dude. If you just gotta fly to Chicago, and I have an extra ticket actually. I do. Although I think you have
Oh,
to be.
bet.
I think you have to be 18. I think you do. Gabriel, I keep inviting you up to speak. Is it not working, Gabriel? Come up and speak. Can you not speak with
No,
us?
no, no. How about gold? How about we say I'm 18?
Okay. But I think they check.
Okay.
They're gonna check your ID. Do you have an ID? Do you have a fake?
I can get one real quick.
Oh, okay. Oh, it's not working,
Okay, I
Gabriel?
can
Yeah, sorry, dude. Yeah, Discord's weird sometimes. Try leaving the stage and then coming back to the stage, and then maybe I can get you up there.
Okay. Yeah, I'll get one before. I'll get one
There you go.
before.
Let me invite you. I'm gonna invite you
Give
up.
me the
Just accept.
give me the extra plane ticket, and then boom, I'll go.
Boom, dude. Boom.
Boom.
Yeah, you just gotta fly to Chicago next Tuesday. I guess you could drive. I've done the drive from Houston to Chicago. It's not that bad. It's like 2 days.
Today?
2 days. It's 2 days to
Oh.
drive.
How much is the plane?
I don't know. We can check. You want to check real quick? Here, then we'll do some questions.
Yeah.
Let me just let's see how much it would cost to get Graham out to Chicago right now. All right, we're not going for LAX. We're going from Houston. Excuse me. What do you mean double Houston, Chicago? Why could I not find these things? Excuse me. Oh, it's just nothing working today. Excuse me. I'm like clicking. I'm clicking on the calendar. It doesn't want to do it. Okay. That's great. Okay. Whatever. Expedia. We like Expedia. It's another website that works. I'm going to. We want a flight round trip from Houston. You probably all airports because you can fly from Bush or Hobby, and then Chicago. Also all airports because you fly into Midway or. All right. So let's see. You need to show up the 21st, Grim, and then you got to go back the 26th. Let's see how much it would cost you. I'm curious. Because I do have some people that are like on the fence, but like they got a last minute buy. Dude, this is cheap, bro. What? Look at that. $248. $250. $250 round trip.
I don't have 248.
Oh damn.
Hey, how about gold? How about you like lend me some?
How about I lend you some? Yeah. Okay. Yeah.
How's it going?
I'll pay you back.
What's up, Ramton? We're just looking up flights and stuff. I don't know.
Let me some drugs.
Flights?
Yeah, Grim was joking about how he wants to come meet me in Chicago next week, and I was wondering actually how much it would be to get a flight last minute. It's not that bad. It's like $250 round trip,
Yeah, that's pretty good.
right? I think what's happening is the economy is kind of like tanking, and people aren't buying things, and so now the airlines are like, oh, maybe we actually need to like lower our prices.
Yeah, I wonder if it's the bottom of the. I feel like it's starting to recover maybe a
Yeah.
little bit. Mostly because I just look at
You look at
the
rental
stocks
prices
I bought.
or stock prices. Yeah, stock prices are a big one. Yeah, right.
I bought them at a very bad time.
Yeah.
I bought them
Uh-oh.
like I started investing in like end of 2021.
No,
And
dude,
so
that was the end of the hype. That's the top.
yeah. So like I lost so much money. Everything I bought was also good.
Okay.
But pretty
But
much
it was
I checked,
inflated. It was inflated
yeah,
back
I
then.
checked today and I'm up now.
Oh,
Overall.
good.
Yeah,
Yeah, you gotta hold.
Nvidia is popping up. Nvidia
Oh,
is
yeah.
like making massive amounts of money. Like
Mm-hmm.
everything I bought a bunch of tech stocks, and
Yeah.
Nvidia has been up like 38% during the past 3 months.
It's 50% in the last month.
No, oh, it's like 68%.
Dude, it's been up 150% in the last 6 months, and then year to date, it's doubled, or tripled. It's tripled.
Can I say something?
What's up?
That's crazy, bro.
1 minute.
It's really because of this big announcement here. This huge jump here is when they basically announced that AI is the new thing, and everyone's going to start using their AI CUDA cores and stuff, and everyone's like, oh, let's all go buy NVIDIA stock.
I still think it's going to go up because their next quarterly is going to be announced
Okay.
at the end of June. So I think they're going to hit 500.
Oh, wow. That would be dope. That would be dope.
I
have an ETF, I think, in tech stocks, and I think it includes a lot of NVIDIA, so mine's
Which
probably
one
going up
is it?
too. I don't
Is it
know.
the
It's
S&P?
it's whatever my like default in retirement grad school thing was. I don't know. I just they
okay.
take money from you, and I was like, oh, put it into tech stocks. Like,
Yeah.
Can I
yeah.
say something?
What's up, Teacup? What's up, dude?
So you guys are talking about stocks.
Yeah.
So we did a stock simulator with the real stock of stuff,
Okay.
and it was on my birthday. I invested into a penny stock. It was like 20 cents.
Oh dear.
I bought like 20,000 stocks in it. It went up to $100,000. And then when I sold it, it didn't give me the money.
Oh dear. Yeah. Penny stocks are a scam. What?
No. It wasn't because it was a scam. It was because the website broke.
Oh yeah. No,
Wait,
I
what?
don't know. He probably had some like you know they talk at like paper trading, right? Where you pretend that you have the money and you see like how you would do. It's all
Oh, yeah,
gambling.
yeah.
It's all gambling, dude. Especially if you start doing derivatives, like options and whatnot. That shit is just straight gambling.
Yeah, I mean options. I wanted to buy options.
No,
for
dude.
Nvidia.
You'll lose your socks, dude.
I would have made so much money, but
I
I
know.
don't have enough. Because the thing is,
You have to buy like
I
100
don't-
contracts, right? You got to buy like
yeah,
contracts.
you have to buy 100 contracts, which means that if I wanted to buy, 100 shares per contract.
Per contract, yeah.
Which means that if I bought one contract, I would have had to drop 40K.
I don't think, but I don't. No, you don't buy out the contracts though. You buy out the right to purchase the contract, but no one ever actually buys the contract because you just sell it to somebody else. This is the whole.
Yeah,
it's a game. You wouldn't actually have to purchase that many shares.
yeah. I didn't know how it works, so I didn't want to.
Don't do it. Don't
Because
do it,
I
man.
knew I can sell the contract.
Yes.
But I was like, it would have been nice if I did have the money, because
Yes.
I could have just if I did buy it, the day that I decided to buy it, the share was $3.98,
Okay.
and it was $10 a share
Okay.
for the contract, which means that per contract it was $1,000.
Yeah.
So I was like, okay, I can drop $1,000, but
Right.
then if I want to do that, then I don't know
If you can buy it outright at the end, yeah, you don't ever buy it outright.
No.
Nobody,
because
almost nobody does that.
Given me the right to buy it at
Correct.
$3.98.
Yeah, knowing the basic concepts of how like sorry, how derivatives such as it's not swaps is the other name for it. What I literally just said it, dude. What are we talking? No, what are we talking about again? Sorry.
Options.
Options, yes. Okay. The basic like strategy behind how option works is cool, but then it starts getting into all these things called like the Greeks, right? And all the they call them like all these like theta and whatnot. And you're betting on like the third moment derivative of how the stock price is moving. And I'm just like, what? Like, stop.
Like the what's it called? The like there are I've heard that there is ways that there are strategies to how you want to uh
Yeah, it's this stuff,
do
dude.
like the option trading as well.
It's this stuff. It's this stuff. People just like I know just like oodle over like what all these numbers are, like delta, theta, gamma, vega, options sensitivity to volatility, right? How sensitive the
Yeah.
price of an option is relative to interest rates. Like what, dude? All these like, it's just gambling.
I'll take a look at this. Actually, can you send me this link?
Yeah, yeah. Oh, you just type in the
Yeah.
here. I'll send it, but like literally just type in the Greeks and options trading. So here's the main
Greek
problem
trading.
with options trading, is that you can lose all your money very quickly, right?
Pretty much.
Because if you set your strike price or you whatever at and it expires right before it hits that, you lose everything. Which in traditional investing, a stock is very rarely going to go to zero, so you're very rarely going to lose all your money. But in options, the options can become quote unquote worthless, and then you lose everything. And I've had buddies that make a bunch of money on options, but then the problem is they get cocky with that, and then they lose all of it.
Yeah, I think with like with the uh, with the invention of AI and everything.
Yeah, right. Oh yeah.
I feel
Oh
like
man, the
now
stock. Yeah.
we are at the right at the edge of where AI is useful because
Uh-huh.
eventually where everyone's gonna start using it, then everything is just gonna run off of the same exact data.
Sure.
So
Exactly. So then it's just
it's,
redundant.
it's like the whole strategies, like because I read some strategies that used to work for a while and then everyone starts doing it and
Uh-huh.
then stops being
Uh-huh.
useful. Like for example, you buy Mondays, sell Fridays. You
Right.
buy the or you want to do the opposite. You buy at the end of the month, you rebuy at the beginning of the month. These were like things, or like you buy after the holidays,
Mm-hmm.
or sorry, you buy in the holidays and then sell like afterwards. Because at the end of the year, everyone starts dumping stocks because
Well, they get their
the
bonuses, and then they're like, "Shit, I gotta buy Christmas presents." You know. Yeah.
exactly.
It
And then
goes.
they also want to make sure that they inquire the losses that they have,
Uh-huh.
so they sell and then rebuy back. So
Yeah.
a lot
And buy back shares and
a
stuff.
lot of
Yeah.
the things, yeah.
Yeah. This is again, it's a whole world, and I have buddies that do this a lot, and they make a lot of money. They do. It's cool. But it consumes your life. I know these people because they're checking their phones every day. They're waking up at 6 a.m. for market open, and I'm like, bro, what are you doing? Like, and at the end of the day, I this is where I get upset. Is like, what are you doing for society? Because all you're doing is like rubbing your hands together and hoping it makes more money, but you're not
Yeah.
actually providing any
Like,
value.
6 a.m. and I realized it. 'Cause
Oh yeah,
this
no,
is-
6 a.m. because on the West Coast, in order to hit East Coast open, yeah, you got to be up at 6.
Yeah, that's true.
And all the market moves at 6 a.m. Apparently, it's just like, and I,
6:30, I guess.
yeah. Well, there's pre-trading, right, and whatnot. Yeah, I don't know. It's
Oh yeah, I guess. Yeah, I feel like having the honestly the easiest way of trading stocks.
Yeah.
Is become a politician. You get insider trading info.
yeah. Just call up Nancy Pelosi, dude.
Yeah.
Dude, yeah,
She's just beating every hedge fund.
She is, dude. Dude. The Nancy Pelosi. Have you seen the Nancy Pelosi ETF? Where like they have an ETF based on everything that Nancy Pelosi does, and then you
Yeah, no,
you
there's
just buy. And the
there's
Jim Cramer inverse one. That's another great one.
I haven't heard of that, but
You-
there is a website. For whoever is also listening,
Yeah.
make sure you tread very lightly with stocks, because
Yeah, please.
you know you just
Oh.
have to make sure that it's very volatile and you could lose a lot of your money. Like I was
Yes.
very lucky that I'm always very cautious, so the amount of money that I put into my stock
You're okay with losing.
was a very, like, I think a fifth or like the sixth of the amount that I wanted to put. And so I was like, I'm gonna like try to do it regularly, because you know what, good thing, if it's good, then sure, I'll become rich. But if I make a bad decision, then all my money is gone.
Right.
And I lost 54% of my portfolio when I did it.
Oh, okay.
But now I like slowly made it back up, and now I'm back up again. And I think it was because one, I picked a bad time to start trading. I mean,
Sure.
that one was kind of not my fault, but I think the smart decision was to not put all of my stuff into stock.
Right. And also, you have to hold. is the big thing. The people who are constantly like being emotional and selling, like had you sold when you lost all your money, you would have gotten none of it back, and then then you realize your losses. Yeah, it's a whole thing.
Yo, how
My
did I get into
dad, I'm pretty
crypto?
sure he invested some, and I believe he's holding on to it right now.
Who is sorry?
My dad.
Oh, your
I
dad.
believe he invested some, and he's holding on to it. Yeah.
That's good. Yeah, no, I mean you should like long-term plays. You should hold on to
You're young.
stocks. Yeah, what if you're young, Ramton? What do you say?
My dad and his parents are all investing into some currency and all that. And
Oh,
they're holding on to
Forex.
it.
Forex is a whole other thing, dude. You start getting into like foreign exchange currency stuff. I know buddies that do Forex. That's another one.
But I would say if you're young, just never sell.
Never
'Cause
sell.
You'll have the time.
Yeah,
right?
you do.
It will
Yeah.
eventually go up. And I think the biggest things, like some of the best investors, like if you're young, you got the time as well.
Yeah.
Like I feel like, first of all of these people who make lots of money as well, like hedge funds and everything, they even out throughout the long term because they want to make money in like short period, but like long term it evens out. But the biggest thing is pick based on how good the company is. Because if the company is a growth company, you're gonna make money.
Yeah.
And if it's not, then it's kind of like even if you make your money, you just have to make sure you take it out at the right time. Like for example, one of the stocks that I bought was for these like vaccine companies.
Okay.
And it like went up super high and then it dropped back down again.
Right.
So like made no money.
You gotta ride the hype. Ride the hype train. Ride the rocket. I mean, the classic one that is GameStonk, right? GameStop.
Yeah.
When the GameStop was going up to like 500 a share, dude, I'm just like, chill. Like what? Y'all are nuts.
I don't know if you know the long story of GameStop with
with the Citadel. Yeah, I know the long story. Yeah, how it was a short squeeze and whatnot. Yeah.
Yeah, and then fans pretty much like screwed over big hedge funds, which was like
it was cool. Yeah, no. The problem is that I think it was cool in that regard, but I think it still was kind of a pump and dump because I think there was a lot of FOMO. A lot of people lost a lot of money because they got in. They're like, we're gonna fight it to the big man, and it was them just trying to like stir up more and more. It's a pyramid scheme eventually, right?
Yeah,
You are a pyramid.
I am I'm pyramid gold.
Capitalism. You can't compete with people with big money. Doesn't matter.
No, you can't,
People
dude.
put their money together.
All right, cool. All right, let's start. Let's go through some questions. I like this is a good discussion. We should do maybe some stock stuff for Golden Hour tomorrow. I think it'd be cool.
Yeah.
Cool.
I turned 16. My mom's gonna see with her coworker if she can get me a job and maybe a credit card too.
That's cool. Yeah,
So
no, that.
I'm planning on possibly trying to go and look into some crypto or something.
Okay, don't buy crypto with a credit card though. Don't do that. I don't think they'll let you anyways.
Yeah, I feel like with crypto, it's just a big gamble.
Dude, crypto is all trash, dude. I mean, it was great. The idea was great, whatnot, but unfortunately, you got a bunch of people that started getting suckers in. I'm just like, uh-oh, not good. We can talk about that here. All right, welcome everyone to Office Hours. My name is Dr. Gold, Sexual Education. I'm joined here by Professor Rampton. Love it. And dark aspect, yes. We have a lot of cool people. It's Wednesday. I love Wednesday.
What about me?
And Grim. Yeah, we got everyone here. We got new Gabriel. You're new. Gabriel, how'd you find our server, dude?
I got an invite from my friend Lawrence.
Oh, cool, dude. Thank you, Lawrence.
Lawrence sounds like a cool guy.
Yeah, Lawrence is a stand-up person. Helped you find. Yeah, well, I hope I hope you're finding the server like cool and whatnot. We help out a lot of people with like homework questions and stuff during the school year, and then even during the summer, we just learn math and science stuff. And you can earn prizes and shit for asking questions, participating, and we give out like video game gift cards and stuff. That's what we do. That's kind of it. Yeah. All right. Let's see who's got the first question of the day. It's Noise. Dude, Noise has the first question. Noise chose violence this morning, dude. Noise, you chose violence. I know you did.
Looking common area.
Okay.
Gwen Stacy.
Okay, what? Gwen Stacy or something? What's
Yeah.
up? What's up with Gwen Stacy?
Look what she.
Oh, this
sent.
question, dude. Excuse me. What fuck is this, dude? What? Excuse me. What? What? Someone just typed in a bunch of things into Wolfram Alpha. That's nuts.
For real.
Cool. All right, cool. To BH, I'm homeschooled. Yeah, homeschool is cool. You know, I kind of like homeschool people basically. All right, let's see.
Hmm.
I really need Hypatia for this question, honestly. Like, what is this question?
I can work through
Do you know how
some
to
of
work
it.
some of this? Okay, cool. Rampton,
Yeah.
you help us out with this one.
So-
This is kind of a high-level math question, so heads up, if you don't know any of this, don't worry about it. Just try to, like, follow along a little bit. You'll pick some stuff up.
Yeah.
I don't
So
know if
here's the
I know
thing.
this or not.
Up until part A, in this part,
Yeah.
actually like I think the question is I've studied this. This is like elementary abstract algebra, so like it's not that complicated. I'll have to remember what the word order is, in order to
Okay.
be able to do part B and C. So if Noise wanna hit me up with the definition, and then the Lagrange theorem as well. I remember what it was, but I forgot. So I have to do like a quick review of this.
Sure.
But I think this is a good opportunity to tell people about like, high level math. It's not gonna be scary because like I'm gonna explain it in like very basic terms, and then
Mhm.
you're gonna understand what a group is, and you're gonna understand what's like some of the uses and
Ooh,
all
nice.
this stuff, modulo 20, all this stuff.
I'm down. Yeah, let's
Okay.
learn.
All right. So, first thing is when we want to talk about groups, we want to have a thing. We have a thing called a set. Now, the definition of the word set is just like, what do you consider a set of things? It's a collection of things, right? So that's what this is. It's
I got a set of
collection.
Pokemon cards, So this is a set of
Exactly.
numbers. Okay, cool.
Yeah, this is a set of 1, 2, 3, 4, 5, 6, 7, 8 numbers,
Okay.
right? So, and now the thing is, sometimes sets can be finite, and sometimes they can be infinite. So, this is an example of a finite set. Finite means you can count the number of elements in there,
Mhm.
right? So, we count this, we get 8 elements, and that's nice. So, there's the size of this is 8. Now, an infinite set, for example, could be an example of all of the positive numbers, let's say.
Mhm.
So you could have a set 1, 2, 3, 4, 5, dot, 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 dot. And this keeps going forever, right?
Yeah.
So this is an example of an infinite set.
Has
Okay.
no end.
Has no end. Yeah. And then, once we get comfortable with the idea of finite set and infinite sets, we can talk about like countable and uncountable. But for now, let's just stick with things that are the most intuitive
Okay.
things. Okay. So now, first of all, we already have the idea of what's considered a set.
Uh-huh.
So that gives us the elementary definition
building
or
blocks.
elementary information that we need to start talking about groups.
Okay.
Okay. Now, the next thing is groups have a binary operation.
Binary means
Now,
either 1 or 0, right? Just two. There's two. Does it mean there's
or it
two
means
operations?
things, right? Yeah. So any sort of operation that needs two things to be fed to it,
Okay.
then you have a binary operation.
Okay.
For example, addition is a binary operation. I can't do 2 plus 1.
2
right?
plus what?
So it would be 2 plus 3. So
Okay.
it takes two things to be able to add. You can't add one thing. Like, it doesn't make any sense.
Right.
This is 5. Another example of a binary operation is like multiplication. So 2 times 3.
What about encoding? What about encoding when we say like 5 plus plus?
That one is just like adds 1 to it every time.
Right. I guess it's technically a binary operation, but to me it looks like, I only had to do one thing.
Yeah, I guess. Yeah, it's like a recursive binary operation, pretty much. With
Okay.
that one.
Cool.
Yeah. So yeah, for the most part, most of the stuff that we see from like middle school, high school, and all these stuff.
Yep.
It's the binary operations. We
Okay.
see addition, multiplication, subtraction, and division. Now, when you get to higher level, you would start to see operations that only take one thing. So, for example, a derivative
Uh-huh.
is an operation that monic, I think what they call it.
Okay.
Is that it takes one thing. So when you have a derivative, you can give it like a function, right? And then it applies to this or it operates on that, and it gives you an answer.
What about also if we did like, what if we did like the sine, for instance, of like pi over 2? That's also a monic operation because you're only putting in one thing.
Yeah, so we can say sine is a operator and
Good.
it operates on one thing. Yeah,
Okay.
that's a good example. Yeah, so sine of x, if you want to think of sine as being like a function, it takes like one thing. So if it's an operator, we can think of it as operates on one input that you give it.
Right. I always like to explain to the kids like the whole function thing is it for me that I always think of like a microwave, where a microwave is the operator or the function. The input is you put popcorn in, you put like, you know, like a bag of popcorn. The operator or function does something, and then the output ends up being nice, juicy, buttery popcorn you get to eat. So
Yeah, exactly. Yeah, typically operators are things
I'll be
that
right
don't
back.
have meaning
Cool,
by
Gabriel.
themselves. So like
Yeah.
if sine is mostly considered as like a function rather
Mhm.
than a operator, but I guess there could be like it could be thought of as operator as well.
Okay.
But a derivative I think is a better example of like a monic operator.
Okay.
Right? It takes like one thing. If you don't know what derivatives are, that's fine because like we are talking about groups, so we don't even need this.
Yeah.
Okay, so we now know the second part of this. So group is a set that needs to have binary operations satisfied. Now, there's a few things that makes a group like there are a few conditions that needs to be met. Now, one of the first things is that it needs to be what we consider the terminology to be closed. So it's closed under a binary operation.
Okay.
Okay. So for now, we know the word binary operation, like addition, typically tends to be addition as well. For this one, it's like multiplication, right? Now, what does the word closed mean? Closed means that if I take two elements from this set, so like everything within this is considered an element.
Mm-hmm.
So one is an element. This is what we call the set of all natural numbers, for example, right? 1, 2, 3, 4, all positive integers are considered natural numbers. So before we get to this one, let's think about if natural numbers is closed under addition. Now, closed means if I take my operation, so let's say for this one, we want to go operation addition. Okay. If I take any two elements within this and I add them, then the result has to be something that is also within this set.
Okay.
So for example, 1 plus 3 equals 4. 1 is an element of natural numbers.
Mm-hmm.
3 is an element of natural numbers. The operation is addition, and 4 is also within my set. So because 4 is within my set, then this is closed, for example.
So, a set is closed under an operation if every operation gives you another thing in that set.
Exactly.
So, wait, natural numbers is all positive numbers? Is that what we say?
Yeah, natural numbers are all positive.
So natural numbers would not be closed under the operation of subtraction then, right? Because I can subtract two natural numbers, but I get a negative number, which isn't a natural number.
So that was
that's cool.
what I was going to say. So like,
okay, perfect.
The proof of this sometimes becomes a little bit more tricky, but we don't want to get too abstract right now. We want to understand these abstract concepts in
simple terms.
And that was a good example. So for example, 1 minus 3 is minus 2. Minus 2 is not within this set.
Right,
so we say that natural numbers is not closed under subtraction.
Okay, cool. Okay, that makes sense.
Also, I know that not closed might
not closed.
Like
can we say open? Can we say it's open?
But open has a completely different definition. We will talk about open things it's a little bit like we talk about closed sets and open sets later as well. So the closeness is a concept that when we're talking about operations, it means this. But when we're talking about openness, it's going to be a little bit different. It's a little
Right.
bit trickier, but it's not the opposite of closed. So
Okay.
that's one thing I can say.
Okay.
Okay. So another thing is natural numbers is also closed under multiplication.
Correct. Yeah, because you multiply
So-
two positive numbers, you're only going to get a positive number.
Exactly. So natural numbers
Sure.
closed under multiplication.
Oh, here's a good question for the students. Do you think natural numbers is closed under division? Let's see if anyone can get this.
Go with yes.
You're going to go with yes. Why do you say yes, Gabriel?
I have no clue.
50-50 guess. Okay.
So let's think
Yeah,
about it a little bit. Think about a few examples in your head.
Yeah.
When we say closed, it means that you have to take any elements,
Mm-hmm.
any two elements essentially. If you divide one by the other, you're gonna get a whole number. Now, let's say if I take 1 and if I divide it by 3,
Yep.
is that what the answer is? 1/3, right? Does that make sense?
Yep.
Yeah.
So 1 divided by 3 is 1/3, or 0.333. Just keeps going. Okay, so is this part of this set? Can you find 0.33 in this set?
Yeah.
Well, so
Where?
so point 0.33 though, Gabriel, right? That's a decimal. Whereas natural numbers are all just whole integers, is what we say, positive integers. So, since 0.33 is a decimal and there are no decimals in what we say, well, that's a good question. Have you had to go through like what natural numbers, what real numbers, what integers are yet? Have you had to do that, Gabriel?
Yes, I'm in grade 9.
Okay, cool. Then yeah, you should know this. That's all right. Yeah. So what we're saying here is that like 1/3, right? That's a fraction, which is a decimal. But natural numbers are not decimals, nor are they fractions. So we would say that the division of these two numbers does not produce a number that's also natural. That kind of makes sense?
Yeah.
Okay. Okay. Yeah, keep going, Rampton. You're good.
Yeah. Yeah. So because 1/3 is not within this, because 1/3 is like less than 1, or you can think of it as like, let's say 3 divided by 4,
Right.
right? Or let's take a bigger number, like 7 divided by 4, right?
Ew. I don't like that
7
number.
over 4 is somewhere between 1 and 2,
Uh-huh.
right? There's nothing between the 1 and 2 in here that we can find within this set, so this is not part of our set.
Right. But 8 divided
Okay.
by 4 would be, right? 8 divided
8
by 4
divided
gets
by
us 2. 8 is a
Yeah.
natural number. 4 is a natural number.
4
2 is
natural
also a
number.
natural number. So this is a case where
Exactly.
division would be, I guess, closed, but it's not for the whole thing, right? It's only for those two
Yeah,
numbers.
so when we say closed, it means if you take any two elements,
Any two elements.
then
Yeah.
the operation should work.
Okay,
Right?
cool.
So this is the cool thing about math as well, is that there's no exceptions in math.
Right.
If you find one example where it doesn't work for something, then your proof or your theorem is incorrect.
Yeah, unlike chemistry
so-
where there's exceptions everywhere.
Yeah, pretty much. Yeah, so for math, a lot of the times, people don't look to prove theorems
Right.
because it gets too hard.
Right.
So a lot of the times they try to prove it wrong.
I see.
Because proving it wrong, you need one example in
Yep.
order for it to be wrong.
Right.
But in order to be proved right, you need to prove it for every possible case.
Right, which that's a huge pain. Yeah.
So with this one, it's like if you can find, it's a lot easier to show that it's not closed
Uh-huh.
than it is closed. Because for closed, you have to take every element to be true.
Yeah, you got to consider everything. Yeah, that's a mess.
Yeah.
Got you. Okay, cool.
Okay, so now we come to the modulo 20.
Yes.
So I wanted to also maybe erase some of these stuff.
You can so you can always hit the right arrow and it'll just go to a new board. You can just put someone on a new board. Yeah, there you go.
Okay. So, yeah, would you be able to post the question again here? Just so
Yeah, I got you. Yeah, so I go back here, copy, and then we just go here, paste.
Nice. Yeah.
Cool.
Yeah. All right. So we have talked about the word set.
Uh-huh.
We've talked about the word binary
Operation. Yep.
And we also talked about close,
Good.
right? Or closeness,
Good.
right? Where we say a set has to have a binary operation and elements of that set have to be closed under that operation.
Why do they have to be closed? Is that to form a group they have to be closed?
Yeah, it's what we consider to be a group, because then it would have a bunch of properties, and so we want to make sure that everything stays within itself.
Oh, here's
right?
no, sorry. So okay, so wait, a group is a set that is closed. Is that what we're saying?
A set that is closed under an operation.
It's called a group.
Yeah.
Wow.
Well, there's more.
he's like there's a little bit more, but that's a simple explanation.
But yeah, this is like one of the first things.
Okay, cool.
So,
I like that. All right, because I've never understood what groups are. Again, I have a PhD in physics, but I've not like anytime someone says group theory, I'm like, no, dog, I don't do that shit. But okay, I feel better because I kind of know what a group is now.
Okay. Yeah. So we'll try to work through as much
baby steps
as well.
Baby steps.
Yeah. So I'm using this question to like teach a few things, and then maybe I can finish with like the definition of a group. But there's like 3 criterias for a group to be met.
Sure. It's okay. You don't have to go through all of them. It's okay.
Yeah. I'll see. But they're very understandable. Like there's things that we've already talked about. A lot of people understand them. In terms of like addition and multiplication. They already understand a lot of these things.
Okay. Cool.
It's just a fancier definition of it because in simpler terms we can understand it, but we want to make sure that you can always make new groups, and it would not always be as trivial as we know from like natural numbers and addition.
Right. Okay.
We can form complex things from it as well. Okay, so now we're gonna go to modulo 20. So modulo 20 means that every time something gets passed, every number can be written as a modulo of 20 by we first take a number divided by 20 and we can find what's the remainder of that number.
Yep.
And then that number would be equivalent. Those two numbers would be equivalent to one another. So let's give you an example. So let's take the number 47. If I divide this by, I don't know, is this how you guys do like the?
Oh
division?
Yeah. No, we
want to do long division.
We do it this way. We do 47 and then we do this.
Okay, let's do it that way. Yeah. So 47 and 20, we put 2 in here. We get 40, and then there's 7 remaining.
Good, 7 remainder. Yep.
So this is the remainder of this.
Yeah, sometimes we write this as like we say this is like 2R7 is what we say.
Oh, okay. Okay, that's cool as well. Yeah. So another way of writing this is 47 mod 20 is equals to 7 mod 20. Okay, so how you can think of it is that if you were to go through 47, you can, let's say, write down all of the numbers, but you're only allowed to go, we should also have 0. We can only go up to 19, right? It's almost like how we are always talking about mod 10 pretty much. Every number that we kind of have is that we go up to 9 and then we start from the top again. We put a 1 on the other side.
Okay. Yeah, so we're saying that you can only have remainders up to 19 because if you had remainder 20, that would just be another multiple of 20.
Yeah, exactly.
Right?
So then it would come to 0. So you can start at 0, 1, 2, 3, 4, 5, 6. You go all the way. Once you get to 20, you go back to 0 again.
Yeah.
and then you go back to again 20, or it would be like, let's say 40, and you go back to 0 again.
Yeah.
And then you count 7 more and you end at 7.
Yeah.
So you see, you kind of cycle through these, right? And that's what mod 20 does. It cycles through these numbers, right?
Yeah.
So 47 is like, you can think of it as it's 2 cycles of 20, and then is 7 remainder.
Yeah. Okay. Okay.
Okay. So, for example, what we can do is let's show that this thing, for example, like we take 2 or 3 of this element, and we want to show that these are closed under the binary operation multiplication. Okay.
Oh, so you're saying
So-
if I modulo one of these numbers with 20, I'm only gonna get another number in this set.
Yeah, exactly.
Oh,
right?
that's cool. Okay.
Obviously, all of these are smaller than 20, so
Yes.
because that's the whole thing, is that when it's modulo 20, you can't have a number bigger than 20.
Right.
But let's take 13 and 17 because they're the biggest ones, just so that we can see how this works. We multiply these two, right? So we get 1, 2, and then 91 plus 130,
Uh-huh.
1, 2. Okay.
221.
So
Okay.
221. Now, if we take 221 divided by 20, you get 11. You
Mm-hmm.
get 220, which gives you a remainder of 1. Now look, this 1 can be found in this set.
Ah, okay. Okay, I didn't see this. It's multiplication then modulo. So they're saying like let number 1 times number 2, and then all of this. We write modulo as this. We use the percent sign.
Oh, okay, yeah.
And then we're modulusing it with 20. And students, what this means is I'm dividing these two numbers I'm multiplying together. I get a big number. I divide it by 20, and then whatever my remainder is, that number here, which is the remainder, needs to also show up in my original group of numbers that I had.
Exactly.
Or a set of numbers, sorry, not group, yeah.
Exactly.
Okay.
Yeah. So the moment that they told us that this set is under binary operation multiplication forms a group, it means that we already know that
Jesus, it's taking
if we
forever.
Oh, you learning something here, Teacup, at least? I'm learning a lot.
I will get one for me. I'm watching Spider-Man right now.
Oh my god, you kids, dude. Ramton's giving you a wealth of knowledge right now. This is an absolute wealth of knowledge, and you're watching fucking Spider-Man?
Listen.
God damn it. Keep going, Rantom. I'm learning. I appreciate it.
Yeah.
I'm
no
sorry.
worries.
There will be a recording. Actually, you know what? I'm gonna make a fucking question out of this, and you guys are gonna have to rewatch the recording to get it.
We're gonna have to.
Yeah, there's
next
homework.
Thing, if you
There's
answer
gonna be
the
homework.
question correctly,
There's gonna
you
be
get a
homework.
bomb.
Exactly. I'm gonna make a challenge out of this one because this is cool. Keep going, Ranton. You're good.
Yeah. All right. So another example. Let's do one more example. Let's take 2 of the simpler numbers, 7 and 9.
Sure.
So 7 times 9. Oh, that's 6. 7 times 9 is 63.
Yep.
63 mod 20 is going to be, well, 20 goes 3 times to 63,
Mm-hmm.
gives us a remainder of 3.
Yep.
3 is in this set.
Good.
Okay. So now, when it says forms a group, you don't have to check for this already, but we now have the idea that this is closed under multiplication.
Yes, it's cool.
So every time we multiply any of these two numbers together, we get an answer, and then if we take that answer and we do mod 20, which means if it's bigger than 20, then we divide and take the remainder.
Yep.
Sometimes it might just already be a number smaller than 20.
And then
which,
that's
you
just
know,
the
mod
modulus. That's
20.
the remainder. Like 4
Yeah.
divided by 20, the remainder of that is just 4.
Yeah, exactly.
Okay.
And so now we have an idea what mod 20 is as well.
Cool.
So this has already given us a lot of new information that, you know, a lot of people might have not known.
I didn't know.
So-
I didn't know a lot of this. I mean, I knew modulus, but I didn't know all the group stuff.
Yeah, so that's good. Okay, so the thing is, now let's think about what a group is.
Mm-hmm.
And And yeah, since we have 10 minutes, we'll go through the 3 conditions. I'll give examples from like maybe one of them.
Yeah.
But all of these make a little bit of make more sense when we think about like something simpler. So I'll go to a new page as well.
You want me to bring the question over, or?
Yeah, sure.
Okay. There you go.
Just so that. Yeah. Okay. So now we want to talk about what a group is. So a group is a set closed under a binary operation.
Yep, we learned that earlier.
So we know what a set is.
Mm-hmm.
A collection of things. We know what a binary operation is, like addition.
Yep.
And multiplication, division, subtraction. And closed means that if we take 2 elements and we do the binary operation to them, then the answer to that is also within our set.
Yeah.
And then this set that has these properties, will have to meet 3 different conditions.
Okay.
Okay. The first condition is association.
Ooh, is this where we're gonna do the associative property, the commutative property?
Yeah, so a commutative is actually not part of a group.
Okay.
So that's actually kind of like a group is like a bigger thing. So like you can put more restrictions on it and everything, and you would get like more stuff as well.
Okay.
Right? So a group doesn't actually have commutativity. So associativity means that for now, because we want to always keep an example in mind, let's take the natural numbers in mind, this set. And for the operation, we take addition in mind. It means that if I do, let's say, 2 plus 3 plus 4, this is the same thing as 2 plus 3, then plus 4.
Okay.
So
means you can group the
if the
parentheses
operation
differently and you get the same answer.
Yeah, or in other words is, if I do the operation between 2 things, and then, or one thing with the result of an operation between 2 things, is the same thing if I did the first and the second, then the third.
Gotcha.
Right? Another way of write this is like you can write A plus B plus C is equals to A plus B plus C.
Okay.
Okay. And so this is the idea of association or associativity. The second thing is the idea of identity. Now, for identity, you have to have a notion that when sorry, 0 is also part of this set, because in order for identity to be met. Now, if I have identity, then it means that if I take any element and I add to what I consider to be my identity, then I will get the same exact thing. So if I take 2 plus 0, I still get 2. If I take like 3 plus 0, I still get 3. So this 0 is what we call identity.
There's something where if like I do the operation, it doesn't change anything.
Exactly. So you see that 0 is the identity for addition.
Right.
For multiplication, now, can you guys think what would be the identity?
Yeah. What can you multiply things by, guys? That the number doesn't change. What's an identity for multiplication? Let's see if we can get it. I want someone to get this. Mr. Bean's coming out, dude.
Yeah, let's see.
I want, yeah. This is also a thing in educating, Ramton, is you always have to like, I always like to try and encourage people to participate with some sort of semblance of a response. Then I know they're doing stuff. Come on, guys. I know you got it. I know you got it.
Someone said it, I think.
Oh, you said. Wait, sorry, Gabriel. I couldn't hear it over the. What'd you say, Gabriel?
0 groups of 1.
1.
1. Yes. Good job, Gabriel. Good job, Gabriel.
So 0. Okay, that's good. So if more than one person's getting it,
That means it's good, dude. Here, you know what?
Timing
You know,
is correct.
Gabriel, you get a bond coin for actually answering a question, dude. Congratulations,
Okay.
dude.
So 0. Nice. All right. So 0 is identity for addition.
Yes.
It means if we add any number to 0, we get the same thing. This is how you can write it a little bit. This is what when you can write it more abstractly.
Right.
A plus 0 equals A. Right?
Good.
And then 1 is identity for multiplication.
I'll be right back to answer stuff.
All right, Gabriel. Cool, man. You're good.
So A times 1 is equals to A.
Good. Also
Anything
for
times
division,
1,
right? A divided by 1. Also
A
A.
divided by 1 is also, yeah.
Good, good. Okay, cool. I like that.
So now the last one is inverse.
Ooh, inverse. Yeah, inverse is
So
good.
inverse is when you take the element. So let's say I have an element, which is like, let's say 2. If I have to perform the operation between this element and something else, which I consider to be the inverse. This is where the inverse goes.
Uh-huh.
Then what I have to get is my identity. So 2 plus 1 gives me 0.
Oh, this is so
Minus 2.
cool. This is cool.
So
okay.
when
Because
come
I was
back
always,
to
I was
that-
worried, I was always wondering why, for instance, the inverse for addition is different than for multiplication. Like, so
Yeah.
with addition, right, the inverse is the negative. So if I have 3, the inverse of that is minus 3. Because if I act 3 on 3 inverse, or the inverse operation for addition, right, that's acting negative 3, I get 0.
Yeah.
But if with multiplication, if I do 3 times the multiplicative inverse, right, that gets me 1. These
Yeah,
are two different things, but
exactly.
they're both the identity for the respective operation.
Exactly.
Ah,
Exactly.
wow, dude, you're blowing my mind, Ramton, dude. Wow, I've actually wondered about this shit for so many years. Actually, I've been like, wait, why they fuck also? They're also like what? Yeah, okay, this makes so much sense now.
Yeah. So there we go. So 2 plus negative 2 is 0.
Right.
And for if we wanted to think about for let's say the multiplication, then it would be 1 over 2 would be the inverse. So
Right.
how we can think about it is that A plus negative A is equals to 0. So this is for inverse in addition.
Uh-huh.
So we have to get our identity. You see, as a result, we have to get our identity.
Yeah, that's
Then
cool.
we have to have A. I'll write it to the side here. Then if we have A times 1 over A, we get 1.
Yes.
This is the inverse
For multiplication.
for multiplication.
Yes.
And this is our identity for multiplication.
That's so cool. I forgot that the identities for addition and multiplication are different.
Exactly. So now let's take a look at this set that I've put in here, up here, and then we're gonna add one more thing to it,
Okay, cool.
which is the set.
Noise is asking,
Yeah.
did I not know about additive and multiplicative inverses and identities? I did, but I didn't realize that the definition of the inverse was that it got its respective identity. I just know that the inverse was subtracting, and then the other inverse was dividing. But I didn't realize that the inverse thing has a different is correlated to what the identity is for that operation. I didn't realize that. Maybe it was never taught like that to me. I don't know. Yeah, I know. This is the very cool thing about math, guys, is that like you understand all these small topics like independently and whatnot, but then when you get to higher level math classes, they start to show how everything is like connected. Like everything is part of like this structure that I guess Rampton, it would have been hard to have shown this from the beginning to someone. So they keep things separate as they teach them.
Yeah.
Yeah.
I think, but now I think this is kind of like putting things into perspective. So,
Right.
Yeah, I'll say this as well. Sorry, I have to hop out. I also realize it's
You're
8
good.
here. 'Cause I have another stuff.
You're good. You're
But
good.
just to mention one thing to finalize as well. So if we look at these three conditions, if you look at the natural, this is what we call the natural numbers. It's
Okay.
0. I mean, sometimes I don't include 0, but let's include it for
Okay.
for
Yeah, let's include 0.
and some people do, some people don't. But if you look at the natural numbers, it's closed under a binary operation. Let's say addition. Then it meets association.
Yeah.
It meets identity.
Okay.
But it fails under inverse.
Yeah.
Right, because you can't find negative number.
Right,
So,
right. Because these
something
are
like-
not part of the natural numbers.
Yeah, because the -2 is not part of it.
Got you.
Now, to extend this, you can write all of these numbers, which we call integers. And this is all of the numbers, positives and negatives, including 0 as well. So now this is closed under addition. So it meets all of the conditions up until 1 and 2. It's not any different than natural numbers. And then it has the inverse as well.
Yeah.
Right. And you can see that when one thing is inverse of the other, then it works the other way around. So inverse for -2 is 2.
Right.
Right. And so we get 0. And then when we have multiplication, again, this thing meets 1 and it's a set. It's closed under multiplication. If we multiply anything, any 2 of these stays within the integers. The association is there.
Right.
Identity is there, but the inverse isn't.
Okay.
So the 1/a is not. So in order to be able to have something that is a group that is closed under multiplication, then we have to include all fractions in there too.
Okay, good. Yeah,
So-
because the inverse of multiplication is division. Got you. Okay.
Yeah. So then we have the a over b, anything that can be written as like an integer over another integer in its simplified form,
Which are rational
Then-
numbers.
rational numbers.
The whole Venn diagram
so-
you guys learned.
This is how we get to so rational numbers is closed. This is closed under multiplication, and it's a group. But
Very cool.
if we look at integers, it's a group under addition, but it's not a group under multiplication.
Okay.
Yeah.
Cool. That's dope, dude. I appreciate that, Rampton. I know you got to run,
Uh,
but
Yeah,
that
so
was a
I'll-
great
well, then-
introduction and stuff.
Yeah, and then we'll see each other tomorrow, I guess, over the AMA then.
Yes, yeah. We'll see each other in the AMA tomorrow, and then and noise. We can finish this one up on Friday too, or something, or we can talk more about it on Thursday. Honestly, I think this was really cool. Cool.
Yeah, all right.
All right, dope. Good to see you, Rampton. I appreciate it.
Hope everyone learned something.
Yeah.
I know for now it might be boring, but we'll get to the cool stuff sometime in the future. It's always
Yeah.
when you're learning something new, it seems boring, but eventually you'll get to a little bit
Yeah.
more useful and cool stuff.
Yeah. Yeah. No, very cool.
Nice.
I learned a lot, Rampton. I really appreciate it, man.
Thank you. All right.
Peace, dude.
Have a good day.
You too.
Bye.
All right, let's see. We got a couple other questions from people. Teacup asks, "What's at the bottom of a black hole, and what happens to everything that gets sucked in?" I don't know. Yeah, there's some weird stuff that happens. Again, I'm not really a Cosmo guy, so like I don't really know. But we can look that one. Let's look that one up on Thursday. I'll give you points for it. Don't worry. Ethan, where are you? Let's do your question, and then I want to play Warzone. Season 4's out. Season 4 is here. Ethan, what's up? Oh, I can't hear Ethan. Sorry. All right, say again.
I said I'm here.
Awesome.
Can you hear me?
Yeah, I can hear you now. Sorry. Yeah, okay, cool. All right. Cool. Have you been learning with noise? You've been learning completing the square?
Yes, I was just doing an example.
That's good. Okay, cool. This is a
See,
cool
I
one.
did get it correct. See, that's cool. The thing is that I actually used a different strategy than what he told me.
Okay. Let me give you one similar to this. Oh, and also try to put headphones on because I can hear myself in your mic. Yeah. Try putting some sort of headphones on. All right. Let's see. Let's say we have x squared minus let's say 8x plus 6. That's a good one. Is equal to 0. Let's try to do this one. Gabriel's typing. Ethan's maybe getting headphones. And then let me see. What else? Whose other questions do we have? Oh, and S6 has a question. Ooh, I like these. These are good ones. This is actually also related to completing the square. The x coordinates of the stationary points. Ooh. And then Habib is a good one. I like this too. We'll go through all your questions. Don't worry, we're gonna get through 'em. All right, Ethan, did you get your mic fixed? What's up? You back? Yes, I can hear you. Great. Excellent. Much better.
Okay, thank you.
You're good. All right. Let's see. Let's see how you do it. How would you complete the square on this one?
Oh, so how I did this is by subtracting 6 by both sides.
That's okay. Yeah, cool. Let's do that. Yeah, subtract 6 on both sides. Good. So I have x squared minus 8x is equal to negative 6. Okay.
Okay, and then the next step I did was that I now divided the one that's near the x.
Good. Which one's that? What number is that?
It's the -8.
Good. Divide it. What do I divide it by?
Negative. Oh, sorry, not negative, but just 2. You divide it by 2 by half.
Good. Nice. Good. 8 divided by 2. That gets you 4, right?
No one.
Yes.
Okay. Then what?
And then you square it. You square the 4.
You square it. Good. 4 squared. Okay. What do I do with that 4 squared?
Then you just have to solve it. Solve what is 4 squared, which is 16.
Okay. Good. That's 16. Cool. Now what do I do?
I'm kind of getting lost. Oh right, I think you put the 16 to the other side, right?
To the other side? I think you want to put it on both sides.
Like, yeah. See, but then it's kind of the same thing because if you just move the 16, it'll become negative 16.
Okay, good. So we're gonna add 16 here, and then where else are we gonna put 16?
Isn't it on our blank space after the 8x?
Good. Yeah. Yeah, we're gonna put the 16 here as well. And it's a key thing here, Ethan. Like whatever you add here, you have to add to the other side as well. It's a rule in algebra. Okay.
But don't you subtract them or something?
Don't you what? Sorry.
Subtract them to cancel them out.
Yeah. -6 and 16 will cancel out. What will those cancel out to?
This to -6, right?
No.
Like, oh, I thought you said 16 and -16, but
yeah,
these
okay.
will it'll be positive 10.
Goodbye. Yeah, this is 10. Good. Very good. Okay. Now what do I do with this?
That's where it kind of confuses me. It's like you gotta put it in like a bracket form.
Yes.
I think it's like gonna be x minus 4 squared. Like that?
It is. X minus 4, all of that. So Ethan, this is called a perfect square trinomial, is what it is, okay? Which means it follows this form. If I have a plus b squared, that's equal to a squared plus 2ab plus b squared, is what this is.
See, that's the part that tricks me. It's like
Okay.
it's kind of getting hard.
So here's my trick for doing this, Ethan. Do you remember how you did 8 divided by 2 and you got 4 and then you squared it?
Yes.
I would always... So, yes, this is 16. I would put that over here. But when I write this one here, I would just write this as plus 4 squared. is what I would say. Like
Oh,
don't actually do the square yet, okay? Just leave it like that.
okay.
And then whatever you have here, it's always going to be this and this with this. So this is always going to be x minus 4, all of that squared. Do you see how this
Oh,
number is the same number as this?
I can see that.
Good. And you can see this also. Again, this is why. Yeah, I remember you told Noise like I don't like foil. Yeah, I hate foil.
You saw that you.
I hate foil. I really do. So if we were to
Because it's
multiply
pretty
these two,
loose.
because it's just ugly. It's just ugly when you get to higher numbers. If we were to like expand this back out, I like doing the Punnett square system here, where I do like x times x is x squared, x times -4 is -4x. X times -4 is -4x, and then this is 16. You get your original thing. Do you see how this is x squared minus 8x plus 16?
Mm-hmm.
And that's exactly what we had here, right? If I were to expand this out, then this would become 16.
All right.
Okay? But the way to keep
And
things
then-
straight is that I'll usually leave this, but I won't actually do the square yet, and then I know to take this number and put it here.
All right.
Okay?
And then there's one other thing that you have to do.
There is definitely there's a couple of things we gotta do, but yeah. So I have this equal to 10. What do we do next?
You have to apparently square root both sides to cancel out the square.
You gotta square root both sides. Square root. Noise says
Didn't that say
foil
square-
is better, dude. No, Noise. Foil is not better. Noise. Tell me how you're gonna foil things, Noise, when it's this, when it's I don't know, like this.
I have to agree with Noise on this one. I feel like the foil is better.
No, not when you get to higher term polynomials. It's terrible. Yeah,
Okay.
Noise. You want to do this, dog? You want to foil this, dog? You want to foil these two things together? You want to do first, outer, inner, last, like
That's what foil stands for.
first, outer, inner, last is what it does. It works fine for binomials, even some trinomials, but dude, anything past that, it becomes a huge headache to keep track of. I prefer the Punnett square. He says Noise says I will. Noise, don't make me say chi-square, dude. I'm gonna say chi-square.
Okay, so.
Okay, what do we do
so
next here?
square root both sides.
Good, we do have square root.
Square
Yeah,
root both sides.
square root both sides. Good.
It'll cancel out the square there, which is just x minus 4.
Good. Very good. These go away. This is the square root of
And then
10.
the next, which is, well, that might be a little tricky because there's no whole number that can multiply 10, that can multiply into 10 by itself.
And I think this is plus or minus technically. It's plus or minus 10.
Yes,
Chi-square
it's
bad.
plus or minus.
Yeah. This is plus or minus. Yeah. When you square this is plus or minus. So then we're gonna do what? What's the last step we gotta do?
You move. Hold on. You gotta figure out what's square root of 10, right?
Oh, I don't know what the square root of 10 is. It's okay. No one knows what it is. You need a calculator
Wait,
for
don't
it.
you?
You can leave it.
Yes, why don't you use a calculator?
You can just leave it. No, leave it. Leave it as a square root. It's okay as a square root.
Nah, I'm gonna touch yourself.
No, dude, leave it. You don't need it as a
I'm-
decimal. This is a common thing, Ethan, is that students think that you have to turn everything into decimals. You don't. Like, it's cleaner. This is what we call exact form because square root of 10 is the exact number. If I tried to actually do like what the square root of 10 is on a calculator, you're not going to get the exact number for it. Because because look how many
It gives 3.1622776.
I know, yeah, right? But are you really gonna write down that many decimal places? Like, look how many decimals. It goes on forever. It goes on forever.
Yeah, like the decimals are infinite.
Yeah,
They
you don't
don't stop.
want to. You don't want to do it. You don't want to do it. Don't do it. Just leave it as square root of 10. It's okay. This is called exact form, which is more correct technically.
All right, and then I think what you gotta do next is like maybe get the x by itself, so you
Good.
add 4 on both sides.
Good. Add 4. Nice. Perfect. Add 4. What are we left with?
So I think it's like x is equal to like the square root of 14. Right?
No. This is 4 plus or minus the square root of 10.
Oh.
You cannot combine these. This is
Oh.
4 plus the square root of 10. That is not the square root of 14. Yeah.
Okay.
The only time you can have things like enter square roots is if you multiply them. So, for instance, if I did the square root of 3 times the square root of 10, do you know what this is?
It's square root of 30.
30. Yes. This is okay. This is fine.
Nice.
This is nice. Yeah. Look at my boy completing the square. I know, dude. I'm very proud of him. Good job, Ethan.
Yeah.
Nice, Noise. Nice,
He teaches me
Ethan.
well.
Yeah, he
He
taught
teaches
you.
me well.
Dude, that's great, dude. I love that, dude. Here, let me add a bond coin to Ethan.
I will go into every detail before we get to the main topic.
That's good. I'm glad. Here, I'm gonna give 2 bond coins to Noise because we answered his question and also because you're teaching people. Noise, I appreciate that, dude.
Yep.
Okay, nice. All right. Let's see. S6 needs to answer. What's up?
I'm gonna have to leave now.
That's okay. Cool. Good to see you, Ethan, dude. Appreciate it. Look at my boy completing the square. I know. Where's S6? Where's S6? S6 needs to answer a question before I buy him a $20 gift card. Where's S6? Where is this man?
This is rigged.
Yeah. Oh, I was talking about your question, Teacup earlier. Yeah, I don't know anything about black holes. You gotta ask me something else.
Ooh.
Yeah, I don't know anything about black holes.
Question.
I don't know anything about black holes. Yeah, that's a better question for golden hour when like Ramton can answer it or something. You should have paid attention. No, here's what I'm gonna do. I'm gonna make you answer one of the questions from Ramton's lecture, and then I'll give you a bond coin. That's what I'm gonna do. Yeah.
Okay.
Yeah, we'll give you a bonus challenge there. Okay, cool. Voke says you're. What's up? What's up, Gabriel?
Nothing. Just
Okay.
keeps spamming me in this game.
Oh, okay. Don't let people spam you. What's up, Voke? Okay. The x coordinates of the stationary points on the curve are. That's a good question. Stationary points. Is this where the second derivative is 0? From your exam? Yeah. Well, I need to remember what a stationary point is. Honestly, that's kind of my first step.
Oh, wait a minute. Gold, I want you to ping me in Discord.
Yeah. Well, I can't ping you verbally.
Nope. Gotta ping me via text chat using @
I know at
left arrow.
Did you get the choice to get? I see a lot of people in the server are changing their discriminators because like they
I
get.
didn't get the choice yet. I'm waiting for it to happen, but it hasn't yet. It's gonna happen like either tomorrow.
Noise says, "Oh, come on, gold. dydx equals p, bro. Yeah, it's okay. Equals 0. Yeah, okay. We call those critical points. I don't call them stationary points. I call them critical points."
See, real quick, Gold. Currently it's August 2019 for regular people. I joined October 2019.
Ah, I see.
So I'm probably gonna be like the next one. But the issue is there, I have no good username available.
Maybe do teacup 1 or something. I don't know.
Never. I'm not putting a number in my name.
Never putting a number, yeah. Yeah, so I use the term critical point, Noise. Sorry. Stationary points only work for one real variable, one dimensional or whatever. Okay, that's cool. Whatever. I would have said these are critical points. But yeah, this should be whatever critical. All right, cool. Yeah, so what they're asking here, S6, is they're asking where is the derivative of this? Where is dy dx equal to 0? Okay. So the first step here is I got to take the derivative. So what's the derivative of this, S6? Ooh, it's a good one. It's a good one. What's the derivative? I know you got a Vogue.
3, 2, 1,
Mr. Bean's coming out, dude. He's coming out. The 3. No, not the 3. You got to take the derivative of this. We got to do d dx of x cubed minus 3x. I know this is something Jamarcus can do. Jamarcus knows how to do this one. Noise said, did you know I don't know how to find the points of inflection? Yes, you do, bro. What? It's for the second derivative of 0. It's easy. Come on. Voke, how do we take a derivative? How do we take a derivative? I might have to teach you derivatives, but you should know this. Screen's coming out again, dude. You don't remember. Okay. All right. Well, that's okay. We're going to relearn then. Okay. All right. Here's how you take a derivative. If, for instance, I had like 5x to the 4th or whatnot, here's what you do. You take this top number, you multiply it by the front number. Okay. So that's 4 times 5, which equals 20. And then you take this exponent and you drop it by 1. So this is going to go down to 3. So this becomes 20x to the 3rd. Does that make sense, Vogue? Does that make sense?
Hello.
What's up, Teacup? Ah, Vogue remembers. Okay, cool. All right. So, knowing that, what would the derivative of this be? Yeah. It's okay. It's coming back. Coming back, dude. You're coming back. What would we do with this one? 3x squared. Yes. Take this, bring it out front. 3x, drop the power by 1. 3x squared minus, and then what does this one become? Sometimes it helps to think of the x as like just x to the 1. 3. Yes. 1 times 3 is 3, and then this becomes x to the 0. X to the 0 is the same thing as just 1. Anything to the 0 power is 1. Except I think 0 to the 0. I think 0 to the 0 is undefined. We don't like that. Okay, cool. So that's what the derivative is, okay, right? And we want to find out, so critical points or stationary points is where the derivative is equal to 0. Okay? So I need to figure out where this thing is equal to 0. How do I solve this? See if you can solve this. What do we do next? This is algebra. Y'all know how to do this. It's just algebra. Pretty basic algebra. Zero to the 0 is indeterminate? Oh, okay. That's what I thought. Folks says, ooh, this is algebra. Algebra. Remember, we're trying to isolate this variable. We want this variable by itself. So I'm going to find whatever is furthest away from it, and I'm going to do the opposite thing. So you swap it. Kind of. I mean, by swap, I would just add 3 to both sides. So that gets me 3x squared is equal to 3. Okay. Yes, good. Yeah, move the 3 where the 3. Yeah, good. Okay. Then what do I do with this 3? What do I do with this one? Divide and then find the square root. Yes. Good. We're going to divide both sides by 3. X squared is equal to 1. Square root that. Okay. So I get x is equal to, remember when we do square roots here, it's plus or minus technically. Plus or minus the square root of 1. Square root of 1 is just 1. So it's just plus or minus 1. Okay. So the x coordinates is going to be this one. It's going to be choice A. And you're done. Nice. Good job, S6. Hi, Gwen. What's going on? You want to come to the stage and talk? You can come talk, Gwen. It's all cool. Tell us a little bit about yourself. Or not, you know, whatever you want. Good. Oh, I think Raiden plays Brawlhalla. He plays a lot of Brawlhalla.
Hello, gold.
Yeah, what's up, Teacup? What's up?
Is it my question now?
Oh, yeah, for the whole Ramton thing. Well, let me see if Habib's here. One sec. Habib, you here?
This is just rigged.
Okay. All right, let's see. All right, here's a good question. All right, let's go. Well, okay, but here's the thing though, is that you're going to have to have had paid attention to what Ramton was saying.
Okay, well, let me just pull up the VOD real quick.
Let me do it after the stream. So you can at least like watch it. Yeah, cuz I don't want to read
What, you're just going to ask me in like office hours Discord
Yes.
channel?
Yeah, I'm just going to ask you something today. Later today. I'll ask you something. You're good.
You're going to forget it. I'm going to die of a heart
No,
attack.
you can tag me. Remember. Where's Habib? Where's Habib? I want to do Habib's question. Habibi. Bum, 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 bum. I love this. Like, everyone's like kind of teaching each other now in the Discord. Where is this? It was an
I've
officer.
taught you how to do bugs.
Look at this. See, look, Jamarcus is teaching about derivatives and secants and stuff. Dude, this is super dope. I love this, dude. This warms my heart. And yeah, I really like Noise now doing these sections where like going over different topics. Like here, for instance, was quadratics. Here are these. I think you can see here. These are all the threads. You can see all the threads that Noise has been talking about. This is very cool. Particle physics. Yeah, very cool. I like this. Threads are dope. Very cool part of Discord we can get into. Okay, cool. No, take the Discord off. You said, I swear I've done this question for someone before. Yeah, I want to do it for Habib, but where is he? Can you solve this, sir? Gwen, you're hilarious. Gwen asked me if I could solve this. This is something where you need Simbo Lab, dude. Like, what? Like, can you solve all this? Like, what? Solve this for T? Yeah, what? Why? I wouldn't want to do this. Okay. All good. He's not here.
I'm gonna say for that it has to be T1.
I wonder if maybe it's T equals 1 or T equals 0. I don't know. This looks a mess. Also, like, this has to equal something. This has to. You have just x of t, but you know you don't have anything that equals. Oh, Habib is here. Oh, what's up, Habib? Let's do your question, dude. Sorry for making you wait so long. We had a lot of people today. Oh my God. All right. All right. If ax plus 2 times bx plus 7 is this, for all possible values of x and a plus b equals 8, what are 2 possible values for c? It's a good one. Do you know how to do this, Habib? Not really? Okay. Well, the first thing we're going to want to do is we're going to want to like multiply these 2 things together. Okay? Just to see what we get. This is where I'm not going to use foil. Sorry, Noise. I just really don't like foil, dude. It's okay. So I'm going to do ax plus 2 times bx plus 7. All right? This is going to be abx squared. This is going to be 7ax. This is going to be 2bx. And this is going to be 14. Okay. Kind of. Okay, so now if I write this out, I get abx squared plus 7ax plus 2bx plus 14 is equal to 15x squared plus cx plus 14. Okay. Noise says use foil. Never. No. No. Okay, here's what we do. Let me combine these two. I'm going to say this is 7a plus 2b times x. That's what I'm going to say. Plus 2b. I'm going to say all this times x. Okay. This is a very important thing that we do in math a lot of times, and what it is we're going to go term by term to look at the coefficients. Okay? So, for instance, notice how on, or here, let me move this over. Let's notice how, for instance, we have a plus 14 and a plus 14. Okay? That's cool. That checks out. I don't need to worry about that. Okay? All right. But now let's look at, for instance, like what's in front of the x squared. So here we have an AB in front of the x squared. And in here in front of the x squared, we only have a 15. Okay? So since these are the only two things with x squareds in front of it, I know that this stuff has to equal this stuff. So I'm going to say AB is equal to 15. Now, if we look at the term that's just x, so like x to the power of 1, okay. Dude, it withheld the word bite me for, it said like provocative chat is what it said. What it said sex-based terms. It's kind of weird. Okay. This means that 7a plus 2b has to equal what's in front of here, which is also 15. Okay, very cool. And then the last thing we know is that a plus b is equal to 8. Oh, not equal to 15, sorry. Equal to c. Dude, I'm so dumb. Sorry. This is equal to c. Okay. That's cool. So I got 2 equations, 2 unknowns. Actually, I got 3 unknowns. I don't know c either. Okay, that's where I need a third equation. I need this. A plus b is equal to 8. Okay. These are my 3 equations, and I need to solve for what c could be. I think you are mod. Or no, you're not mod. Sorry, you're mod in the gaming chat. I need to make you mod in this one. Yeah, you're good. Okay. How do we solve this? This sucks. This is kind of like this because this is non-linear right here. Is what this is. Yeah. Okay. What I can do is I can rewrite, for instance here, I can say that b is equal to 15 over a, okay? And then I can plug that into both of these equations, okay? So here I'm going to get 7a plus 30 over a is equal to c, right? 2 times this. And then with this one, I'm going to get a plus 15 over a is equal to 8, okay? I'm going to solve for A. I mean, we could solve for B. I'm just going to do it for A. Because what I'm going to do is I'm going to multiply this whole thing. Oh, man. This is non-linear, though, dude. This is non-linear. If I multiply the whole thing by A, let's see what we get. That gets me 7a squared plus 30 is equal to C. And then this gives me a squared plus 15 is equal to 8. Oh, I think I'm getting it. Okay. Multiply this whole thing by 7. Okay. So now I have 7a squared plus 105 is equal to 56. Let's replace that. Okay, cool. This is actually kind of a cool question. Okay, and then I'm going to move the 56 over. So that's going to be 99. Yeah, plus 99. Okay, it's equal to C. So now if I subtract these two, okay, that gets me that negative 69 is equal to C.
That was fun.
Oh, 15 by 7 in my head? Okay, because 7 times 10 is 70. 7 times 5 is 35. Add the 2, you just get 105. Okay, so 69 is C? Is that right? Is that even like one of the answers? No? Oh, we're all sorts of fucked. This is wrong. Oh, dear. All right, let's see what I did wrong here. Sorry, this is a little tricky. AB is equal to 15. I agree with that. 7.
I'll be back in a moment.
Okay, cool. You're good. 7A plus 2B is equal to C. 14 equals 14. I almost want your solution, Noise, but I'm confused why this doesn't work. B equals 15 over A. Like, shouldn't this work? Oh, I forgot to multiply this shit by A as well. Oh, uh-oh. I see what I did wrong. Ew. 7A squared minus CA plus 30 is equal to 0. And then this is A squared minus 8A plus 15 is equal to 0. Can I set these equal to each other? Yeah, because both equal 0, right? Okay. So I have 1 sec. Maybe this will come out nice. This equals this. Minus A squared, right? Okay. So I get 6A squared plus 8 minus C times A is minus 15 equals 0. Okay, and now this is a quadratic equation, right? Yeah, maybe send me your solution, dude. Yeah, because now, like... Yeah, I'm curious about this. One.
Which ratio is equivalent to...
I mean, I could also just, like, plug numbers in just to make, like, this work. I don't know. Is A going to be, like, 3 and 5? So 21 plus 10, 31. I'm just looking for, like, what numbers work here, right? Okay, so if A is 3, that's 21 plus 10. That's 31. Cool. This is 31. 3 plus 5. Okay, cool. That's the easy way to do it. It's like, once you get to here, just try to see what numbers of A and B would get you different values of C. And, yeah, it ends up being this one. Yeah.
I'm not going to do good on my QL.
Anyways, that's a tricky question. Noise, I want to see your solution. It's probably more elegant, but nice. Good job, Habib. Are you live on Twitch? Yes. Always live on Twitch. Here's it's twitch.actual. There you go. Go Cinefall. Okay, cool. All right. That was cool. Thank you. Yeah, it's Twicky. I think it is Twicky. That's a Twicky question. Okay, cool. All right. That was kind of tricky, but all good. Okay. Thank you, everyone, for coming to Office Hours. Had a lot of fun learning with you guys today. I really appreciated Professor Rampton's explanation of groups and stuff. I don't know. I think that's something we're going to do probably over the summer is, like, kind of learn some more advanced math topics. I think Hypatia wants to get involved doing some stuff, which I'm super down with. Okay. So now we're going to do... So we learn a little bit, and then we play a little bit. And today's game, Wednesday, is Warzone, which Season 4 just came out. So I'm very curious to see how this game works. Or if I think they added a new battle pass or something. So if you want to come join us on actual gaming, just stay in the Twitch, and it's gonna bring you over there. Our next stream is gonna be tomorrow. It's our AMA Golden Hour. where we'll answer anything about everything. I know we have a lot of questions from the last golden hour that I still need to go through, so we'll probably hit some of those up. And then yeah, so here there's my username. What else? What else am I thinking about? I think that's it. Okay, cool. All right, if you guys want to come play Warzone with us, we're going to do that in the Recess voice channel in the Discord. Join our Discord, please. There are a lot of people coming in, and that's where we announce everything. But if you're on the Twitch, it'll automatically take you. Okay, good to see you, Teacup. All right, let me start the raid off. He says, I'll be seeing you, dude. I'll be seeing... You're waiting for your question, dude. I'm going to give it to you. Don't worry. All right, we're going to raid over. I will see you guys over there. Let me see. What else do I need to move? Need to move this off.